Okay, the graphs of the sine, cosine, and tangent functions are shown here. Are the inverses of these functions also functions? We learned earlier this year that a function that has an inverse is a function if the original function's 1-to-1, which we can check with the horizontal line test. So you can see here when I'm looking at my trig functions that they're functions because they pass the vertical line test, but they're not 1-to-1. So you note that for each function, the horizontal line, which I showed in red, crosses the graph more than once. Therefore, none of them has an inverse that is a function. Now, the graphs below that, where we switch the x and the y, are the graphs of an equation and its inverse. Okay, so the x's and y's switch. So we have x equals sine y, x equals cosine y, and this last one here is x equals tangent of y. Okay, so let's examine these graphs, the inverses of each of the three functions graphed above. And note that they are not functions because they all fail the vertical line test. So, the inverses of the trigonometric functions are not functions. Okay, so how do we go to restricting the range to define the inverse functions? Let's go back to writing the definition of what is a one-to-one function. Okay, one-to-one function is a function where every x has one y and every y has one x. It passes the horizontal as well as the vertical line test, and because it's one-to-one, it can have an inverse function. All right, so write that down. And then your inverse function is a reverse function. And when you reverse a function, you switch the x and the y, you switch the domain and the range, and you use the inverse operations. It says add, you subtract. If it says square, you take the square root, like that. Okay, so let's take a look here at the quadratic function. Okay, y equals x squared, right here. Okay, you can see that it is a function. However, it is not 1-to-1 because it fails the vertical line test. So when we go to write its inverse relation and switch the x and the y, we get this graph that fails the vertical line test so that it is not a function, right? And so how do we restrict that? The original function so that we can find an inverse function and we can answer questions about it and everybody can come up with the same answers. So if you look here, I've taken, let me erase a couple things here. I've taken the quadratic equation and I've restricted it to just the non-negative values for x. Okay, so that now not only is it a function, but it's a one-to-one function because it passes the vertical line test, so that I can find its inverse function. And my domain here is restricted from 0 to infinity, which means I'm going to be restricting my range down here from 0 to infinity, because remember these two things, when they're inverse functions, they switch. So we're taking the inverse of x squared and we're finding the square root of x. And you can see that in purple here, that my inverse function is actually a function because it passes the vertical line test. And now we could agree that if I want to find the f inverse of, let's say we have, never mind. Forget I said anything about that. We'll just do this in terms of trig. Okay, so we are going to learn to restrict the range of the trig functions here. So let's come down here to restrict the range. So in a similar manner, we can define the new trigonometric functions whose inverses are also functions. To do this, we're restricting either the domains of the basic trig function or the range of the inverse relationship. This can be done in many ways, but the restrictions illustrated here below with the solid red curves are fairly standard in mathematics. So for the inverse sine function, we're going to choose a range that's close to the origin that allows all of the inputs on the interval between -1 and 1 on your domain, okay? So that we can get all the function values. It gives us all the inputs, which means we'll get all of the outputs that go with those inputs. Okay? So we're choosing from negative pi over 2 to pi over 2 for the range. Okay, and that's going to happen in quadrant 4 and in quadrant 1. For cosine, let me see, for the inverse cosine function, we choose the range close to the origin that allows all inputs over the interval negative 1 to 1. So you can see here from negative 1 to 1, I'm just going over that again with my pen, you're getting all of the inputs that are possible there. So this time your range will be from 0 to pi, which is from quadrant 1 to quadrant 2 when you're on the unit circle. And then for your tangent function, for your inverse tangent function, you're going to choose a range close to the origin that allows all real numbers that have function values. And so you'll get a full branch of your tangent function, and that's over the range open from negative pi over 2 to pi over 2. So we are going to be working in 10.1 in quadrants 1, 4, and 2, and that's it. Okay, so here's some notation, and you want to get used to this notation. So when we're working with inverse notation, this says y equals sine inverse of x, and please be aware that that does not mean sine to the negative, excuse me, sine to the negative 1. Okay, that says sine inverse of x. And you're also going to see this alternate notation here, arc sine of x. Okay, the notation arc sine of x arises because of the function value y is the length of an arc on the unit circle for which the sine is x. Either of the two kinds of notation above can be written, above, here's what I mean, above here, can be read as the inverse sine of x, or the arc sine of x, or the number or angle whose sine is x. And so it's the same thing, and so there's your domain restriction, there's your range restriction for your sine inverse. Again, that's quadrant 4 and quadrant 1. Okay, here's your cosine values. Okay, and then here's your tangent values. So I have all of those recorded for you, and that's important. And what I did here was I just restricted our functions to just our prescribed domains and ranges for all of our inverse sine and cosine and tangent inverse functions. I said that twice. Okay, all right. And also below, what you'll notice here is you have some blanks to fill out. Here's our arc sine. This is quadrant 4 and quadrant 1. And what's happening here, here's the arc sine right here. You can see it. It's this arc on the unit circle that I'm kind of outlining here. Okay, and what you need to remember is that these values represent your sine of an angle. Okay, so now when I say things like this, guys, the sine inverse of the square root of 2 over 2 equals what angle, you're able to go to just the one angle where this is actually true, and you can say, oh, hey, that's 45 degrees, or that's pi over 4. And you don't have to wonder if it's 45 degrees or if it's over here at 135 degrees where the sine of x is also the square root of 2 over 2, because we are restricting to this section of the unit circle. Okay, so fill in those values for your unit circle, and you can see that that covers all the way from negative 1 to 0 to positive 1. So you get all of the possible values that you could get for your sine inverse function. And then come over here to your cosine function and fill the values out for your cosines. So when I ask a question like this, the cosine inverse of the negative square root of 3 over 2, you can go straight to your unit circle here, and you can say, oh, well, that's 5 pi over 6, or that's 150 degrees, and everybody can agree that that's the one answer that we're looking for. Okay, so fill those out. Oops, fill those out on your unit circle as a reference. And then we're going to come to your arctangent here. Now arctangent, things that we have to remember here is that our range is restricted between negative pi over 2 to pi over 2, but we are keeping those open. So you'll notice on my circle here that I have these little open circles, so you could add those to your picture if they're not there. And remember that tangent is sine over cosine. So what I did here was I just divided my sine by my cosine. So 0 divided by 1 is 0. 1 over 2 divided by the square root of 3 over 2. After you simplify is the square root of 3 over 3. Square root of 2 over 2 divided by itself is 1, etc. And then you get here to pi over 2, and 1 divided by 0 is undefined. And then when you come down here to the bottom, of course, those values just become negative as you rotate to negative pi over 2. Okay, so these are the values that you will be looking for. I didn't mean to erase that. These are the values that you will be looking for when I ask a question like, okay, guys, what is the tangent inverse of the square root of 3? And you can go, oh, well, that is 60 degrees, or pi over 3. Okay, and then down here, what I also added are your cosecant inverse, your secant inverse, and your cotangent inverse. Okay, and then you got your restrictions here in our domain and our range, so you definitely want to study those values. Okay, and then here's your arc cosecant, or your secant in your cosecant inverse. Remember that all that means is that you're taking your sine and you're flipping it over. So 2 over 1 is 2, and 2 divided by the square root of 2 is the square root of 2, and 2 divided by the square root of 3 is 2 square root of 3 over 3, and 1 divided by 1 is 1, and then 1 divided by 0 is undefined. So you've got a little hole in your graph right here, so make sure you put a hole in your graph, and then of course reverse to go to the negative direction. And there you have that. So you would do the same thing over here for secant as well. Secant, you just remember, is here's your restrictions up here, your arc secant or your secant inverse restrictions. Okay, let's see, what was I going to say? So this time you're working on secant. So secant, remember, is 1 over cosine. So all you're doing here is taking your x coordinate and you're writing its reciprocal and simplifying it. So you're going to want these values 1 and 2 square root of 3 over 3, square root of 2, 2, undefined here. So it's got a little hole in the graph. And then go to your negative side. And then for your last one, your arc cotangent here, just remember that cotangent is cosine over sine. So now we're dividing 1 by 0, which is undefined, and square root of 3 divided by 1, square root of 3, and just cruise around and get all of those values. Okay, that would be really good. Another thing you could do is you could go here to your exact value trig functions, and you're going to see in quadrant 1 all your values for cosecant, secant, cotangent, and tangent. You have all of those values there in quadrant 1. And then here's quadrant 2, and this will be useful when you're doing your cosine and your secant and your cotangent. You'll get all of your negative values for those in quadrant 2. Then down here on the very bottom in quadrant 4, what might be really useful is to change these values to their negative values. So this would be negative 30 degrees and a negative pi over 6, and this would be negative 45 degrees, or negative pi over 4, and this would be negative 60 degrees and negative pi over 3, and this would be negative 90 degrees or negative pi over 2, and here's 0, of course, 0 degrees and 0 radians there. And that way you could just have this out when you're working on your inverse functions, and you'll be able to identify what angles we're looking for quite quickly. So you could just make that adjustment on this adjustment here on your exact value trig sheet. It'd probably be pretty useful to have that. Okay, so definitely have that filled out and ready whenever you're doing any of your objectives for 10.1.